Section 21.5, Plate Tectonics. So based on this idea of continental drift and the understanding of seafloor spreading, scientists established a theory known as plate tectonics, which describes the motion of Earth's lithosphere. In this description, the lithosphere is divided into 8 large plates, and then there are many other smaller ones. The lithosphere essentially rides atop the asthenosphere, and the continents ride on top of those plates. So the plates essentially sit on top of the asthenosphere, and all the stuff is up above that. The plate motion is caused by those convection currents within the mantle. Right? So the dense rocks move down, the less dense rocks move up, and that causes the mantle to move. But because that type of convection current is not uniform, plate motion is not uniform. Plates move at different speeds, they move in different directions, and they come together at regions we call plate boundaries. And understanding what happens at each of these plate boundaries tells us something about what happens on the Earth. So there are 3 different types of plate boundaries. The first are divergent boundaries, and this is where plates move apart from each other. The second are convergent boundaries, and this is where plates move together. And then the third type are what are known as transform boundaries, and this is where plates slide past one another. So here you can see just an image of the different plates on the Earth. And notice there are 8 really large ones that make up the large continents: Australia, Eurasia, North America, Africa, South America, Antarctica. But then you also have some smaller plates. And I want you to kind of pay attention to where a few things are, because these plate boundaries matter because things happen there. First of all, if you look around the Pacific Ocean, if you know what the Ring of Fire is, well, that is this general area. But I also want you to notice that there is a plate boundary in Western California, which is where you would expect there to be earthquakes. There are volcanoes in this region. There is a huge mountain range down here. And one of the greatest earthquakes ever recorded was in Chile, which is right along this boundary. You also have regions like Japan, which sit right on top of a plate, and there you experience earthquakes and tsunamis. Go around to the other side, and though this is kind of cut off, here you have India, and then just north of here, these are the Himalayas. These are the highest mountain range in the world. And so I'm going to refer back to this picture in just a minute just to show you what I'm implying when I talk about all these different things. But first we need to talk about the different types of boundaries. So divergent boundaries are where plates spread apart. In this region, the lithosphere is thin and the asthenosphere is near the surface. Most divergent boundaries are located in regions of mid-ocean ridges where plates under the ocean separate. Magma rises up, it cools, it forms new crust, and it forces the seafloor to spread, and thus it forces the continents to spread. The mid-Atlantic ridge is between North America and Eurasia. It spreads about 1 to 6 centimeters per year. So if we just go back and look, here's the mid-Atlantic ridge between Eurasia and North America. And this here is a divergent boundary. These 2 plates are spreading apart. And because they're spreading apart, the continents will slowly move apart, and you get uprisings of magma and such inside of the ocean. You can also have these plates spread apart on land. It does not have to happen under the ocean. And those regions are called rifts or rift valleys. One last comment about the mid-Atlantic ridge, because it's not all underwater. Iceland, the country, is right here. And if you go to Iceland, you can see the mid-Atlantic ridge cuts through the island. It cuts through the land. And from the pictures I've seen, you could literally walk in between it. Now, the next type of boundary is a convergent plate boundary, and this is where plates come together. These convergent boundaries are areas where you have compressive stress. So you have rock moving into itself, pushing on rock, and you get a lot of stress and compressions. Here you find that the lithosphere, pieces of it can be destroyed, and you form mountains or volcanoes sometimes. So for example, if you have, let's just say, oceanic crust meet with some other oceanic crust, when they run into each other, you see that sometimes these things will move down underneath each other. So this plate is being forced downwards underneath this plate. When it does that, you see some of this rock will melt and form lava, and you can form volcanic islands. If you have the same thing happen, except a boundary, say, between oceanic and continental crust, rather than two regions in the water, you can still form volcanoes and mountains in the same way. This process of pushing the lithosphere underneath another plate is known as subduction, and subduction leads to partial melting, which leads to volcanoes. You can also have the situation here where you have two continental crusts, one being subducted under the other, and that can form things like mountain ranges. And this is what you see in this region of the Himalayas. The Indian plate is pushing into the Eurasian plate, forming huge mountains, the biggest mountains on Earth. So there are three different kinds of convergent boundaries depending on the type of crust that's involved. You have oceanic and oceanic crust, or oceanic and continental crust, or continental and continental crust. So the final type of plate boundary is what's known as a transform plate boundary. And this is what you get when two plates just slide beside one another. So, one's moving north, one's moving south. They're not moving into each other, and they're not moving away from each other. They're just sliding past one another. In this case, you don't have crust that's created or destroyed, and you don't generally form things like volcanoes. But this is where you have things like earthquakes, more common. You can also have earthquakes at convergent boundaries. So when this plate is subducted under another plate, sometimes this land or this plate that's being subducted can catch. And when it does, it won't move. And then all of a sudden, it'll move all at once and shift. And when it does, you get an earthquake. If it happens underneath the water, you might get a tsunami. But in general, you get an earthquake. So earthquakes occur at convergent boundaries and transform boundaries. Now, the San Andreas Fault in California, probably the most well-known fault line in America, is a transform boundary.